Hi everybody, Cal here with sections 3.1 and 3.2. So we've just finished up what we're doing in chapter 4. We're going to dip back into chapter 3 so that we can learn determinants before we tackle chapter 5. Determinants are our last main computational skill in this class. The other ones we picked up pretty early on. They were just row reducing a matrix and solving a system in parametric vector form. The third one is here, computing the determinant of a matrix. Determinant is something that only exists for a square matrix. We've seen 2 by 2 determinants before, but what we're going to do is we're going to expand that definition into something that can work for any n by n matrix, any square matrix. Go ahead and read the exposition here pretty carefully. You want to work through their example with them, and I understand that this is confusing and the notation is a lot to work through. You want to work through this example and sort of figure out what's going on. So the definition here works fine. It's not a definition you'll want to memorize. It's just a definition you'll want to be able to compute with. And example 1 shows kind of going through this example in terms of computing a determinant. What you can kind of see is that a determinant of a larger matrix is written in terms of the determinants of smaller matrices. So work through these, make sure you kind of figure out what's going on. The formula that's given in that definition is called a cofactor expansion across the first row of A. What the theorem says is that you can actually do a cofactor expansion across any row or down any column. So understanding theorem 1 is pretty key to understanding how determinants work. Make sure you get through that. Work through examples 1, 2, 3. These will kind of demonstrate how to use cofactor expansions. Pay special attention to where these pluses and minuses are coming from here. There's a nice checkerboard pattern with a plus in the upper left that these signs are always going to come in whenever we're doing cofactor expansions. So the main takeaway that I want you to get in 3.1 is how to do cofactor expansion along any row or column of a matrix in order to compute the determinant. Theorem 2 is a nice rule, but you don't want to rely on this. It only works for triangular matrices, and we don't yet know at this point how row reductions affect determinants. We'll learn it in a minute, but you can't just row reduce to a triangular form and use theorem 2. So just be aware of that. Let's move on to section 3.2, which is properties of determinants. And the main theorem here is theorem 3, which is exactly how do row operations affect determinants. Make sure you understand that theorem, and I would work through the examples after this pretty carefully. And pay attention to kind of what happens when it uses scaling operations. Example 2 and the blurb on the top of 173, together with theorem 2 about triangular matrices from the previous section, kind of let us conclude some things about what might be some good practices in order to compute determinants. In particular, what you'll learn here is that a matrix is invertible if and only if its determinant is not 0. And that's stated here in theorem 4. That's going to be extremely important, and we'll end up throwing that into our invertible matrix theorem. Example 3 lets us apply this, which is fine. And example 4 lets us play more with the things we're learning here. There's a blurb here about column operations in the middle of 174. It says that for the purpose of taking determinants, and only for that purpose, you can perform column operations as well as row operations. This won't come up very often, but that's okay. Theorem 5 tells us that the determinant of transpose of a matrix is the same as the determinant of the original matrix. That should be reasonably obvious. And Theorem 6 is going to be super important, that the determinant of product of matrices is the product of the determinants. That's really nice. That's super nice. You can work out an example of that in example 5. You can read the linearity property of the determinant function, but I would not make a big deal of it. If you're not understanding it, don't worry too much about it. And the book does go into proofs of some of the major theorems here, but you don't have to worry too much about them. Again, they use elementary matrices. You know, this might be interesting to some of you, but I wouldn't put much stock in it. The main takeaway here is, how do you compute determinants? Make sure you know how to do cofactor expansions. Make sure you know how row operations affect determinants. And try to figure out some good practices in computing determinants. You definitely do need to know how to compute determinants. So, that's what we've got for these sections, and I'll see you next time.